Bismillah ar-Rahman ar-Rahim. Corona effect. You can see an image for the corona effect. It's actually a power loss, which appears in the form of the violet glow, hissing noise, the radio interference, and the production of ozone gas. It's a chemical reaction. So, corona discharge effect is actually the ionization of the air around the conductor or where the electrical stress is high. So, you can see that as let's suppose example is a conductor, so the air around this will be ionized, okay, because of the electrical stress, um, and this ionization will occur if the external electric field is greater than the ionization potential of the air, which is equal to 30 kV per centimeter. Okay, so ionization of the air will occur, and this is actually a power loss. So it produces a hissing noise, like a hissing noise. Okay, and we can call it the audible corona. Okay, audible corona. So also, mm, a bluish violet glow on the conductor, around the conductor appears. So it's we call it a visual corona. It's a audible, and it's a what, a visual. Okay, so we will discuss these two individually in the upcoming slides. And the production of the ozone gas as well. It's a chemical reaction, and as these are the power loss which appears in the form of the sound or the light or the chemical reaction. So that is why the efficiency will reduced, because the sending end power, the receiving end power will be much less than the sending end power. Okay, and the remaining will be lost in the form of these two. Okay, these three. So it reduces the power system efficiency. Okay, okay, now we will discuss about the audible corona and the visual corona. Okay. When a gradually increasing voltage is applied across the two conductors, initially nothing will be seen or heard. Okay, so when the applied voltage is increased, the air surrounding the conductor gets ionized at a certain voltage, and this voltage is called actually the disruptive critical voltage. Okay, the voltage, the minimum voltage required to start the corona. Okay, to commence the corona, it is called the disruptive critical voltage. Okay, so when we increase the applied voltage, so hissing noise will be listened. Okay, and we call it a audible corona. But it doesn't mean that at the same time the glow will occur. No, the voltage required to start the visual corona is greater than that of the audible corona. So we represent it, the disruptive critical voltage for the visual corona can be represented by the VV, while the voltage for the disruptive critical voltage for the audible corona will be represented by V naught. Okay, and VV is always greater than V naught. Okay, if a further voltage is increased, a visible violet glow will appear around the conductor, and we call it a visual corona. Okay, so these are the factors that are affecting the corona. Number one is the atmospheric condition. Okay, because if there is a humidity, moisture in the air, and if it's a stormy or the foul weather condition, so the chances of the corona will be higher. So it greatly depend on the atmospheric condition. Okay. Also, with the height, the atmospheric pressure will reduce, so the discernible critical voltage will be reduced as well. We will discuss it in the upcoming slides. Okay, so the conductor size also affects the corona. The spacing between the conductors, greater are the spacing, lower will be the chance of the corona. Okay, and vice versa. So the supply voltage is directly proportional to the chance of the corona. Okay, so means if we have the high voltage, so electrical stress will be high and the disruptive critical voltage be reduced, so the chances of the corona will be higher. Air density. Okay, air density represented by the m naught for the audible and mv for the visual. Okay, so it also depends on, it's also affect the corona. Okay, now the environmental conditions. The following environmental facts and condition increases the corona effect. The low pressure condition means the hilly areas, the high temperature areas, the places where at high temperature areas the thermal stresses will now counts. Okay, so the places where are heavy rains means moisture or the snow area, so the chances of the corona will be high. So these are all environmental factors that affect the corona. Okay, so mm, mechanism of the corona discharge. The stress surrounding the conductor is a maximum at the conductor surface itself and decreases rapidly as the distance from the conductor increases. Okay, so lower are the closer are the transmission line, greater will be the chance of the corona. That's when the stress has been raised to critical value. Immediately surrounding the conductor, ionization would commence only in this region, and the air in this region would become conductive. The fact is to increase the effective conductor diameter while the voltage remains the constant. So this results in two effects. Firstly, an increase in the effective sharpness of the conductor would reduce stress outside this region, and secondly, this would causes a reduction of the effective spacing between the conductors, leading to an increase in stress. Okay. Under ordinary conditions, the breakdown strength of the air, which is represented by the G naught. Okay, we will discuss it the last slides. Okay, that is will be equal to 30 kV per centimeter. It's a maximum value, and the RMS value for the breakdown of the air is 21.1 kV per centimeter. Okay. Okay, now the corona will of course be affected by the physical state of the atmosphere. In stormy weather, the number of ions present is generally much more than the normal, and the corona will then be formed at a much lower voltage than in fair weather conditions. Okay, so this reduced voltage is generally about 80% of the fair weather voltage. Okay, so in foul weather it reduces by 80%. It's a huge difference. Advantages, there are some advantages of the corona, but it doesn't mean that for the sake of the advantages we will intentionally occur the corona losses in the transmission line. Though the first advantage is the diameter of the conductor is increased. The increased diameter reduces the electrostatic stresses between the conductors, and the coronal effect reduces the effect of the transients. And some industries uses industries use this effect to remove unwanted volatile organics from atmosphere. Okay, now we will switch to the disadvantages. The corona power loss is actually the major disadvantage of the corona effect in the power system. It reduces the transmission line efficiency because of the power loss appears as the glow as appears as the sound and the chemical reaction of the ozone production and the radio interference. Okay, so corona effect reduces ozone, which will lead to corrosion of the conductor, and it's also uh, hazardous for the health in some condition. Voltage drops occur in the line. The radio and the TV interference occur on the line. Okay, the signal distortion will occur. The corona effect can also damage the line insulation. So these were the disadvantages of the corona effect. Okay, so now how to reduce the corona effect. So the reducing methods includes the increasing of the conductor spacing. Okay, increases the spacing means by the cross arms, by increasing the conductor size. Okay, and using the bundled conductor. This also a very effective method to reduce the corona effect in higher transmission lines. Okay, by increasing the conductor size by aluminum conductors, steel reinforced conductors have a larger cross section area are used to reduce corona effect in transmission line. Okay, these are the aluminum conductors, steel reinforced cables. Okay, and this will helps in reducing the corona effect because of the larger cross sectional area. Okay, and using the bundle conductors can also reduce the losses. Okay, what are the bundle conductors? These are the bundle conductors. These bundle conductors may be in uh, two, bundle of two, bundle of three, and maybe bundle of four. So a spacer will be used to join these conductors. Okay, so these conductors actually represent a single phase. Okay, so for the three phase, four eight more conductors will be used. Okay, 4 plus 4 plus 4, then it will be a complete three phase power system. Okay, so the ACSR conductors have a larger cross sectional area and are used to reduce the corona effect in transmission line, and using the bundle conductors produces less resistance and thus losses are reduced. Okay, uh, out of these, hollow conductors can also be used. Okay, these are used to increase the effective diameter of the conductor without using any additional material. So the material will be saved by using the hollow conductors, since corona loss is inversely proportional to the diameter of the conductor. Corona loss decreases with the increase in the diameter, with the advantage of saved material. So these are the few methods for reducing the corona. Okay, so we will discuss the formulas, and then we will do some numericals regarding power loss uh, of due to the corona in the next part of the lecture. Thank you for the moment.